we're back. So, I wanted to show you this. Okay. So what I did is I used GPT. I set up a, let me cue the music. I set up a range of range tutorials and built it into a comparison program to compare the speeds so you can understand optimizations and how optimization. Just take a look. Okay, so what we have here is a clock function, and this function excuse me, this function clocks, this is our clock. This is what clocks each range. So what we've got here is we've got ranges using IOTA. That's the version we used, okay? Remember Jason Turner? Jason Turner is way better programmer than I am, way better C++, hands down. He's never even used IOTA. Now, that's not surprising the way that he codes. He's been coding since the beginning. So why would he use this junk? He's probably got something faster overall. I mean, he's the guy that showed us the editor that shows us what's fast and what's not. And I was just watching a video on how to turn the optimizations on and off and up through the levels right there in his thing just by changing a single letter. And you can see all the different steps that the compiler is using. Anyway, I want you to see this. How big can I make it before it starts wrapping around all weird? Okay, so with IOTA, it's 1100 seconds, right? It's over double, almost over double, just under double when you use it with a vector. Wow. That's amazing. Now, I haven't looked at these to see if they are really, competition quality. But what the difference is that you need to use things like accumulate, okay? Now, remember, IOTA does the job that accumulate's supposed to do, so I really don't even know what's going on here. But let's just assume that this thing, that GPT created us a fair comparison of different types. And it appears that every single one of them is using IOTA. But this is using different ways. This is different. Excuse me. Excuse me. This is using different functions of like getting different ranges out of a range of numbers. One's doing even, one's doing square numbers. This one's putting it in a vector, and you can see the effects. Now, it's not too surprising that when you put it in a vector, it doubles, because you're basically doing two things. You see what I'm saying? Microseconds, what would that be? 0.0000, and then you get this? Something like that. What's it divided by? Let's see. Modulus of 2. Let me make that bigger so you can read it as well. I'm not really seeing where it's... Oh, it must be in the time function, of course. Microseconds. Now we can do it in microseconds, but if we print it out as... we could try seconds. I'm not sure how much we gotta divide it by. I think you have to divide it by 10,000, because, well, it would be 1,000. Maybe do it twice, and it's not gonna let me do it like that. recognize token. Did I get division? Oops, didn't mean to hit that button. Maybe I did, no? Oh, okay, yeah, that is the division, okay. Let's see what happens. Took 0 seconds, okay, it's truncating it. Ooh. Well, it's because it's not a float. Oh man. And the problem is I could change this to float, but then it's going to change all the code. Now, this is what AI is good at. I want it to print seconds with a decimal instead of an integer microseconds. Instead of dividing by 1,000,000 as in your current code. Is that what I'm doing? Makes sense. 1,000, 1,000, right? Yeah, now it's using a double somewhere. Just in the clock, I guess. Oh, there we go, that's done. Want to see, like, I like the decimal place. You'll see, like that. Now I can understand. This is human readable to me. Like I said though, it's doing more. What is this? Oh, okay, same set of numbers. So, is that a direct comparison? Accumulate, sum, reduce. Basic vector filled with. Huh. I really don't even know what it's doing with the vector there. What is it doing with that vector? It's making a vector of integers size, a vector filled with iotas. Requires numeric for iota. A vector filled with iotas. What? What? It's interesting to see what it does when it interacts with a vector. So basically the overhead of a vector, of vectorizing the iota, like as in you had a whole set of things you wanted to run iota on, a whole set of ranges, and you stuffed them in vectors, in a vector. And it's twice as long to iterate over them because you have a tiny, tiny little hitch where it has to switch from reading that part of the vector to the next. So it's the iteration step. So it's basically taking just as long as iota, which is almost nothing, and then taking just as long, almost nothing, to iterate over the vector, run another accumulate command, which is quite impressive that it's this fast. So now we've learned that vectors maybe not quite as slow as you thought for doing something like this, especially when you're talking the same standard template library that allows you to, it all works internal, I'm sure. So that's why it's quicker. It's pre-compiled. It's optimized by the compiler. Anytime you can use STD that I've found in modern C++, it's always a speed advantage. And if you look at these other types, this is grabbing the even numbers using filter, and this is using transform to get the square, and these take almost no time at all. To be honest with you, if you had a math library and you wanted to like have a range just so that you could just check the square of a range. Can you stop that? Quit that. So, you could easily just get the square of any range, or the average, or whatever, using these ranges, and you might end up with a math library that's literally faster than anything out there because of the way that it's optimized now. But I wanted to show you that. I thought about that and I was like, well, and then I wanted to show you this too. I have to dig it out of here. Actually, that's probably not wise to do on a stream. Yeah, I don't want to go, well, here. There we go. What was it called again? I can't even remember what it was called already. Compiler Explorer. Than this. What? Failed? No. What? It's not a member of STD. In version 19 point latest number 1. Well, we need a newer version of. What is that? That's old. 16, 17, 19. Oh man. Well, that's the latest one, so we can't use ranges? What? Why? All compilation options. How can we use it? Must be a way. It's not a member of STD. Let's try some other compiler. Let's see, what's this? What's the most update one in the world? GCC, ARM64, trunk. Error ranges is not what? Not been declared. Okay. Oh. How do you declare it? Just go through the compilers until we find one, right? Nothing can compile this code. Nothing on here. I wonder if it's just a lack of any more standard template library. Oh, this one almost works. No member name views. Why? Experimental. I don't know if those are old or not. It's just views? Why does it work in Microsoft? That's so weird. Yeah, let's see where views is. This is pretty handy. Oh, ranges views. Well, how come it doesn't work good? Let's see here. It doesn't even say, it doesn't even have one. Views equals ranges views. Huh. That's weird. Is that all it needs? Heck no. It's much more needy than that. Well, I guess we can't use it. Bummer. I really wanted to look at the code behind this. View interface. I don't know. This one works. It's just them, the views. This says IOTA, but this goes directly to STD IOTA. What? Then why are we using ranges? Strange. Excuse me. It must be the pollen or something today. Got everybody sick. Alright. Man, there's a lot of... Yeah, but it's not. I wonder if we can get away with the MSPC. Find it. Here we go. We got a fake allocator. Interesting. Wow. Oh, man, I keep doing that. What is this? Frame chain return. Flag single pro API function length. What in the world? Wow. All that? There's the clock function. There's main. There's the lambda. So it created... Is there lambdas or did it create lambdas? It looks like it created its own lambdas. After deleting destructor. Throw exceptions. So, what are the compiler options? Maximum optimizations. Actually, let's see what this one is. That's not gonna Chrome. I'll have to quit and go get something to eat here, but yeah, it's pretty much the same with optimizations. Let's see what happens if we just take that part out. Pretty much the same. So the compiler pretty much, it just does what it does with the code. It reads the code and optimizes it. Yeah, so I was trying to show a little bit more about optimization, and I mean, I guess we did kind of show how the clock functions work. It works a little differently, and this clock function is really good for clocking any other functions that you want to just stuff inside these. It is a lambda right there, I think, but you could just reuse this, and we can start clocking all our functions and comparing and really nail down what is optimized. So if you were ever unsure of my ability, rest assured, there's lots of unit testing ahead for the Almond engine. Hey DD, how you doing? But anyway, I gotta make a burrito or something. I'm starving, so I guess we'll